In section 7.7 here, we are talking about solving radical equations. So if we think about what that means, we know equations relates to having an equal sign. Radicals means square root, could be the cube root, could be the fourth root, right? So anytime you have a radical with an equal sign, that's going to give you a radical equation. So we're looking to solve these. And remember that when you're solving an equation, your final answer has to be x equals some number. So that's kind of what we're working with here, equations that have radicals, and we're looking to solve them. In other words, we're looking to get x by itself and figure out what number x equals. So let's look over some of the steps here to solve these radical equations. The first thing is that you need to isolate the radical. So whether you need to add, subtract, multiply, or divide some numbers away from the radical, that's what you have to do first. The next thing you want to do is to, and I put this in quotes, is you want to undo the radical. Now what I mean by undo is we know that we have to use inverse operations to get rid of that radical. So if I have a square root, then I need to square both sides. If I have a cube root, then I need to cube both sides. And if I have a fourth root, then I need to raise both sides to the fourth power. All right, so again, every operation has an inverse operation. We're just doing the inverse to try to remove those roots, those radicals. And the last thing, you're just going to simplify until you're left with x equals whatever number you get, okay? And then, again, that means you're done once you get x equals a number. The nice thing about these is that you can always plug your number back in and check to make sure you did the right steps. So for this first example, we have the square root of x plus 11 equals 9. So I see that this the square root is already isolated. There's nothing else on this side, right? There's not like a plus 3 or anything like that. So it's already isolated. And I see that because we have a square root, I need to square both sides. So if I square the left, then I also have to square the right. We notice that the square root and the square undo each other. So I'm just left with x plus 11, and this is going to equal 81. That's 9 times 9. Next step, I'm just going to go ahead and subtract 11 on both sides, and we find out that x is equal to 70. All right, now again, I said you can double check your answer. So if we plug this 70 into my original problem, we can double check. 70 plus 11 equals 9. This is the square root of 81 equals 9, and that is true, right? 9 does, in fact, equal 9. So we know we can get the right answer just by verifying it once you think you've got the right answer. So let's go to the next question. Here we have negative 3 times the square root of 5 minus x plus 2 equals negative 34. So I'm going to try to move this 2, and I'm going to try to move this negative 3. All right, so I know I'm going to have to subtract this 2 first. And when we subtract the 2, we now have negative 3 times the square root of 5 minus x equals negative 36. Because this radical is being multiplied by this negative 3, I know that to undo multiplication, I have to use division. So we're going to divide both sides by negative 3. These negative 3's cancel. And now we have the square root of 5 minus x equals positive 12. I then see that I have a square root. So we said that to undo a square root, I have to square both sides. So we're going to square the left. And if I square the left, I got to keep it balanced. I got to square the right as well. A square and a square root are inverse operations, so they undo each other, leaving me with 5 minus x on the left. And 12 squared is 144. I'm then going to subtract 5 on both sides, again trying to isolate the x, and that gives me negative x equals 139. Now I don't want to know what negative x is, I want to know what positive x is. So if I just quickly divide both sides by negative 1 here, we should see that x equals negative 139. All right. And again, you can check your answer by plugging it in. 5 minus negative 139 is 144. 144 times negative, square root of 144 is 12. and then 12 times negative 3 gets you that negative 36. So you can plug it in here at this step. You can plug it in at the very beginning. Either way, it's going to get you back to that, that correct answer there. All right. Now we've got example 3, and here we see we have a cube root. All right, so not a square root anymore, but a cube root. First thing I want to do is, again, I want to isolate this radical. So I'm going to have to move the 16 over to the right side. So we're going to subtract the 16 on the left and on the right side. These will cancel out here. So now I have the cube root of 2x minus 1 equals negative 2. We said that to undo a cube root, I need to cube both sides. So I'm going to raise the left side to the third power and the right side to the third power. Got to keep it balanced. Cube and cube root undo each other, leaving me with just a 2x minus 1. And then we know that negative 2 times negative 2 times negative 2 is negative 8. We're going to go ahead and then solve this for x. So I need to add 1 on both sides. So we get 2x equals negative 7. Then I'm going to go ahead and divide both sides by 2. And so we find out that x is negative 7/2. And that would be your answer. Okay.